Hello, Mr. Chan here, about to start lesson 1-6 for Algebra 1. If you're following along, we're on page 23 of our note taker, Student Companion. And if you have your textbook with you, you can see further examples on page 37. All right, let's get started here. We are doing compound inequalities. Our opener says Hannah has some blue paint. She wants to lighten the shade, so she mixes in 1 cup of white paint. The color is still too dark, so Hannah keeps mixing in 1 cup of white paint at a time. After adding 4 cups, she decides the color is too light. So let's go and read the question here. Explaining words how much paint Hannah should have added initially to get the shade she wants. So in the picture, we have a paint can with a paint stick and a brush. And we have plus 4C, I'm thinking cups there, white paint, and plus 1 cup of white paint gives you the different shades that are shown in the paint stick. So note that we're going to come up with a compound inequality to describe the color she wants is definitely more than 1 cup of white paint, but less than 4 cups. So the idea of betweenness is represented by a compound inequality. And in this case, we're going to use the letter C for cups. It's going to be between 1 and 4. Between us, you can literally put the letter C for the variable in between those two. That thing I just wrote is literally betweenness. Now remember, 1 cup of white paint was not enough. 4 cups of white paint was too much. I'm going to actually break down this compound inequality into 2 separate things. That is, C is greater than 1 read the other direction. That's greater than 1. Cup of white paint. In the other direction, it's read normally, C is less than 4 cups of white paint. All right, this whole thing is a compound inequality. The word we'll find out together is the word and that connects the two together. C is greater than 1 and C is less than 4. This is called an intersection of 2 rays. It must be true for both inequalities. I think that's a good start for this section. I am going to skip the next few questions on this page. Let me know if you have any questions about betweenness. Let's move on to the next page, page 24. All right. So the idea of having paint between 1 and 4 cups is kind of represented in example 1, another betweenness. Your answer is somewhere between -2, not including -2, up through 6, and could include 6. This thing that we're looking at here, right here, is called an intersection. Happens to be an intersection of two overlapping rays. Rays, you may not know this, are kind of like the sun, and they shoot out rays. One endpoint and goes outward with an arrow. Those are your rays. Great. Let's take a look what's going on here. We have a compound inequality, and by the way, let's read the question here. Write a compound inequality for this graph. Your answer is a segment located in the segment, or line segment, to be specific. And we are literally between -2 and 6. Put the variable x in the middle. The inequality itself is going to be different depending on which end you're looking at. The open circle on the -2 requires an inequality that doesn't have an equal sign. That literally means x is greater than -2 because we're going this way when you read that backwards. On the other half, we're including 6, but we're going to the left from 6. And that inequality is less than or equal to. This one is a closed endpoint. And that's it. I would like to mention that this particular compound inequality can be represented by the two separate inequalities with the word and in the middle, like that, okay? All right. I do want to show you physically what this means. A lot of teachers show it this way. They draw 3 lines representing the number line. So what I'm doing now is showing you, if I had to do this problem backwards, how the intersection works. We're going to look for the overlap. For the first one, I'll do x is greater than -2, and we're going to the right from -2. The second one, I'm going to go ahead and graph to the left. You can change the color here a little bit on that one, since I chose orange earlier. There you go, much better. And the other one, x is less than or equal to 6, is closed. And I'm going to graph that. Your final answer is like coming from sandwich making. You know, sometimes moms, when you were younger, they would make a sandwich and they would cut off the crust. Think of the orange ray that was graphed to the right and the red ray graphed to the left. Those parts that they don't both overlap get chopped off. And where they chop off is the resulting intersection of the 2 rays. Close on the right, open on the left, and that's how you look for the overlap. That portion is the overlap. All right, hope that helps. Let's move on to example 2. Oh, got a pretty complex problem here. Solve the compound inequality negative 3x plus 2 is greater than negative 7, or, that's the key word here. Remember, the previous one involving and meant intersection. With this example down here, the word or doesn't mean intersection, it means something else. Oops, I'm getting in the way. Or means union. All right, before we can actually graph this, we have to separate this compound inequality and solve it individually. I'm going to do the left side, writing a little bigger so you can see it, and the right side. On the left, I'm going to go ahead and isolate x. Subtract 2 to both sides. That leaves me with negative 3x is greater than negative 9. Divide through by negative 3. Now, whenever you divide by a negative or multiply by a negative with inequalities, there's a little thing you have to do. You have to switch the inequality direction. That's a rule in algebra. Negative divided by negative 3 is positive 3. So I'm going to write that down. We're dividing by a negative. When we do that, we've got to switch the direction. Okay? All right. Second half. I guess I could divide by 2 or distribute the 2. 2 will go into 6 evenly, so that's a great option that I'm going to apply and avoid the distributive property. You don't have to, especially if you have a fraction that doesn't reduce on the other side. Great, look at this. Add 2 to both sides. X is greater than or equal to 5. Yay! This is not an intersection, this is a union. Union means just to graph it, actually. Let's do that on the number line here. Let's see, we have a 3 and a 5, we'll put 0 over here. All right. Interestingly enough, the first inequality has an open circle. The second one, though, is closed because you're including the 5. So, oh, I just filled in the 5 and it's pointing to the right. You just graph it. Just do it. You don't have to look for any comment. You just do the graph the array. For 3, open circle to the left. And that's it. That is your graph. Now, before I move on, just a quick recap. When it comes to union, I remember my teaching told me this, just to graph everything. Just graph everything. And before I move on, I want to represent open circles and closed circles with parentheses and brackets as well. I just want to point out that that's something that is also done in algebra, depending on what book you're on. So you'll see something like this, and you see something like that. That's another way of writing those answers. The bracket represents closed circle. The parentheses represents open circle. I'm going to do that up here too, just to say I did. Okay. All right. That's a -2. Forgot about that. Let's keep going. Next page. Sample 3. All right. I guess we're just doing more of the same. We're going to go ahead and do it. Hope you guys can see this. I'm going to zoom in a little bit. Write each problem a little bigger so you can see it better. Keyword here is and. This is an intersection. We are looking for overlap. Let's go ahead and, I guess, divide by -2 first. Because I'm dividing by negative, I do have to switch the inequality symbol. 4 divided by -2 is -2. And the symbol changes. Subtract 1 to both sides. X is greater than -3. Oh, yay. There's 1/2. All right. Let's go ahead and solve for the other half. 4x plus 1 is less than or equal to -3. Let's undo operations. Subtract 1 to both sides. -3 minus 1 is -4. Divide by 4 to both sides. Now be careful. Just because you see a negative somewhere in the equation doesn't mean to switch the inequality. It's only if you multiply or divide by a negative do you switch. Here we don't switch at all. -4 divided by 4 is positive. I'm sorry, -1. Great. Okay. So an alternative, and to save you a little time, let's go ahead and realize that with the first half, this is open circle at -3. So let's find -3. Open circle. And it's going to go to the right. It's greater than. Now, what I'm doing here is to save a little time. Instead of writing 3 separate number lines, I'm just showing where the ray would go. Let's do the same with the other half. This is an and now. It's an intersection. At -1, it's closed. Let's do that. And it's going to the left. Visualize where the green ray goes and where the blue ray goes, and you see that it is in the middle. And there's your graph right there. In fact, I'm going to go ahead and write down the actual solution in addition to the graph just to show you it. This is between us. This is between -3 and 1. And this could also be represented like this. Parentheses and bracket. Yay. We're going to skip example 4. Any questions about example 3? We're going to jump to the last 2 here. This is kind of nice. Nice little break here. Number 5 and 6. We're going to just focus on coming up with the actual compound inequality. All right. So just by inspection on number 5, I see 2 rays, which tells me that this is an OR situation, right? The first one is -4 closed, and it's less than. So let's write that down. X is less than or equal to -4. Or, on the other end, it's also closed. Interesting. This is going to be X is greater than or equal to -1. And that's it. It's a union of 2 rays. That was pretty easy. All right, we're going to make number 6 the last one. This one's a line segment. And line segments are because of a result of something that they have in common of 2 rays. So this is definitely an intersection. We do have on one end a closed circle. And on the other end, we have a open circle. These are pretty easy. You just have to write down the lowest number on the left, highest number on the right, put the variable x in the middle, and just write it down. X is going to the right. It's greater than or equal to when you read that backwards, but it reaches up to 8, but not including 8, so it's less than. You can represent this answer another way too. You need to be aware of that. This is x is greater than or equal to 2, and x is less than 8. This is an intersection. Well, I hope you guys are understanding of this lesson. If you have any questions, let us know. I'm going to go ahead and end it. Have a good day. Peace.